Hi, in this talk we're going to be talking about, we're going to be given an introduction to developing distributed applications using Java. In particular, we'll be looking at using Java's remote method invocation libraries. So RMI is one of the ways in which we can build distributed applications using the Java programming language. So distributed applications have been around for a very long time, for at least since the advent of the internet. So a distributed application is any application that runs on multiple devices, and this has been going on for research purposes at least since the 1960s and 70s in the United States and around the world. So pre-internet they were relatively rare. So they did exist, as I said, but only for research purposes. But since the advent of the internet, since we consumers have been able to use the internet mainly since the 1990s, they've become a lot more prevalent, and there are many, many applications that rely on distributed architectures. And indeed, it is that non-distributed applications nowadays are the exception. So it's very rare these days that you'll have an application that doesn't need some kind of distributed communication over the internet. Even standalone applications, they need to be updated. For example, you'll have something like Microsoft Word or Excel or a computer game it might run on your computer on its own, but it still needs to have some kind of communication of the internet with its parent company or with a server for various reasons, such as updates or for storing data or whatever it may be. So it's very rare nowadays to have an application that's not distributed. Most applications these days are distributed. And examples of distributed applications are mobile apps. So all mobile apps nowadays are distributed. Websites rely on a distributed architecture where, for example, you separate things like how a website is displayed. You put it on, it arrives onto your browser so you can see it, but the actual data for many of the websites is sitting somewhere far away, and your browser needs to communicate with a distant server in order to receive and send data. So we need that distributed architecture. Complex backend services for electronic commerce. So electronic commerce systems will typically have multiple layers, and each layer responsible for something different. So you'll have a layer, for example, that's customer facing, that'll show whatever a company like Amazon, for example, is trying to sell you. So you'll be able to search that layer and find the products you need. But also the other layers that hold customer data, for example, will be sitting on another server somewhere else, or another device. And there'll be other layers as well storing various things. For example, various algorithms that companies use in order to predict what you might are most likely to want to buy. So these algorithms might be running on a different computer. So you'll have different computers, each responsible for different things, running different things. You'll also, in addition to that, have computers for redundancy. So for example, if Amazon has a server that holds all the data for bicycles, for example, they'll have a backup server somewhere just in case their main server goes down, so that they can quickly switch to it in case that server goes down for some reason. Banking also certainly relies on a distributed architecture. So sending, receiving payments, etc. They need to be able to connect with various services all over the internet in order for that to work correctly. So in this talk, I'm going to be focusing on techniques used to build those distributed applications. So why distributed computing, and why are we looking at Java RMI? So we'll be looking at an overview of the architecture of remote method invocation with Java. We'll be looking at things like obtaining references to remote objects and the concepts of marshalling parameters and return values. I'll also be looking at some example RMI applications. So we'll do a coding demo of 3 examples, and we'll discuss some problems with remote invocation that we need to think about as application programmers, and we'll discuss Java's distributed object model compared to the non-distributed model. So here are some reasons for distributed computing. So you might want to, so one of the things that is done a lot, particularly in the research community, is that you have some complicated job, for example, and the job contains, let's say, 100 or 1,000 different tasks. So if you wanted to solve this job on a single computer, it might take a month or several months to complete, because each task takes a certain amount of time, and typically you can't start the second task until you complete the first task. But there are, nowadays through distributed computing, what you can do is you can split that job and its tasks among lots of different computers. Instead of having just one computer to solve the problem, you can distribute it among lots of computers, and they'll each pick up a task, and that way they can complete the project a lot more quickly. Another reason for distributed computing is separation of concerns. So like the e-commerce example that I mentioned earlier, so for example, you might want to separate the products that you're selling on a website from customer data for various reasons. So one reason is security. So you don't want all your customers to have access to a server that holds all the customer data. So you might want customers to be able to see your products, but you don't want them to be able to have access to a computer that holds all customer data, their passwords, their bank card details, etc. So you want to hold that separately in a secure location, and you only want very controlled communication with that server only when required by an authorized either member of the admin team or by an authorized customer. Another reason you might want distributed computing is for fault tolerance. So if faults happening with the server, then you need to be able to have backup, as I mentioned earlier. So you need to, if a server fails, we want to be able to continue processing and for customers to still have access to our products and services through redundant servers. So if a server goes down, another one starts up and picks up where the failed server left off. So we need to communicate between different processes and different address spaces, possible hosts. So in order for distributed computer to work, this is what we need to be able to do. So why are we looking at Java RMI or remote method invocation? So there are lots of much more popular solutions for distributed computing, for example REST and SOAP, but REST and SOAP hide much of the implementation detail. So this is meant to be a kind of a talk to explain what's happening under the hood. So we're trying to show the mechanics of what's happening behind the scenes, and Java RMI is a very good way to do that. It enables us to see a lot of the code and a lot of the mechanics and the individual things that we need to do in the background in order to enable distributed computing. So understanding Java RMI helps us to understand the mechanics of how distributed applications are implemented. So RMI maintains the abstraction of local object invocation. So it essentially enables programs to run as if a remote object in a different address space is a local object in the same address space. And this is essentially what a good distributed architecture enables programmers to do. So it enables them to create computer programs in the same way that you create a computer program on a single machine. Even though you might be invoking an operation or a method on another computer far away, as far as a person looking at the computer program or creating the computer program, to them it should be as easy as creating a program on a local machine. Yeah, so this is what we want to achieve. So for example, let's say you have an application running on one machine here, you have another application running on another machine here, and between them you've got the internet. So on this machine, let's say you've got object A, object B, and object C. So as you know, it's very easy for object A to invoke methods on object B, and object B to invoke methods on object C, and the same on this other machine here. Objects 1, 2, and 3, it's very easy for object 1 to call methods on object 2, and 2 on object 3, etc. So what we want to do, to be able to read these remote invocations as well. So in distributed applications, for example, we want object C to be able to call methods on object 1, and to do so while hiding a lot of the complexity that comes with communication over the internet. Okay, so the internet comes with technologies such as IP and the Transport Control Protocol, and if you want to communicate over the internet, you need to adhere to those protocols and build messages that can travel over the internet using those protocols. So a good distributed architecture hides all those details to the application program, and the application programmer should be able to call methods on objects that are far away in the same way that they do on their local computers. Okay, and here's a look at the Java, a high-level view of the Java RMI architecture, and a high-level example essentially of what we can do with RMI. So on the right-hand side here, we've got a service that we want to be able to access and run over the internet. So the service here is sitting somewhere on the internet, and then on the left-hand side you've got a client computer that wants to be able to run some of the methods and services that are provided by the service. And essentially the way we do this is through the service interface. So remember, all this is written in Java. So Java RMI is a Java technology, and the service interface is essentially the normal interface that you're all hopefully familiar with. So remember that an interface contains a number of methods that contain no implementation within them. And the service interface is obviously implemented on the service side, but the service interface is also used both by the client and by the server. Okay, so the interface is used by the client program to create something called a stub, and by the service side, the interface is also used to create something called a skeleton. And the stub and the skeleton are essentially counterparts to each other. They do essentially the same thing. So for example, when the client program tries to access one of the remote methods on the service side, it programs. So first of all, the client program programs to the service interface. So what that means is that it's a simple case of calling one of the methods provided by the interface, and then what the stub does here is that it packages that method call into a message, and the message is formatted in a way that it can be transported over the internet. So the internet has a specific format in which messages are packaged up, and the stub knows how to do that. It creates the message that can be transported over the internet. And so we make the method call here, then the stub here packages the method call, and then the remote reference layer knows where to send the message call over the internet. So the remote reference layer knows where the service on the right hand side, or its addresses, etc., and it knows how to send the message over the internet to the service. So the remote reference address does that. Obviously, we're using, nowadays, the internet runs on a protocol called TCP/IP. Okay, so all internet programs, all programs that are running on the internet would need to use the transport layer. That's essentially what TCP is. The message goes through the transport layer, and then it goes up through the layers of the service program. So the remote reference layer on the server side inspects the message that is just received, and it sees where it's coming from, so that it knows in future how to reply to it. Essentially, it inspects it, sees where it's coming from, then it sends it to the skeleton layer, and the skeleton layer is doing the reverse of what the stub is doing. So the skeleton layer unpackages the message and converts it into a Java method call. Okay, so it turns it into a Java method call, and then that's intercepted by the Java virtual machine, and it essentially calls the method that the client program wants to run and executes whatever the client wants them to execute. And if there is a return value to return, then the same process happens but in reverse. So it goes the return value or variable or whatever it is has to go through the skeleton. The skeleton packages it up into a message that can be transported over the internet. Remote reference layer already know where the original message came from, so it knows what it's to send it to. It goes through the TCP IP layer, the transport layer, and it goes then up these layers again to the client program, and it does whatever it needs to do with the return value. Okay, so the service stub intercepts invocations at the service interface and redirects them to the remote RMI service, as I mentioned. I think I've covered everything on this slide. So here it says, since version 1.5, the stub is auto-generated using reflection. So in the past, doing this distributed programming was a lot more complex, and this stub here and the skeleton needed to be created by the application programmer. So you needed to write the code that packaged a method call into something that the transport layer can understand. But since version 1.5, it's done all automatically for you through this Java Reflection API. So if you're not familiar with Java Reflection API, then please have a look at it on the Oracle tutorial pages. So you can find these online. So essentially what it does is all you need to do is provide your compiler with the interface, and it will automatically generate the stub, and you don't need to do anything. So that's one of the points of this. Is one of the reasons of that distributed programming APIs are so successful, is that a lot of the stuff that in the past needed to be done manually by computer programmers, nowadays it's a lot more advanced and it's done automatically, so that when you call a remote method, it's almost as if you're calling the method locally on your local computer. Okay, so how do we obtain references to remote objects? So we've got two processes in this example. We've got a client process on the left-hand side and a server process on the right-hand side. And the service process has got two objects. We've got object A and object B, and these are two objects that the client wants to make use of to run some of the methods provided by those objects. So the first thing that the server process needs to do here is that it needs to place the first object inside the registry, so the RMI registry. So think about the RMI registry here like a telephone book, essentially. So it's a way for the client to be able to look up how to gain access to the object. So when the server process places an object in the registry, it needs to give a name, and it also gives back the object stub. Okay, so if we go back to this slide here, remember the client needs to make use of the stub in order to do method calls remotely. Okay, so the stub is generated. Both the skeleton, the stub are generated by the server, and as shown in this slide here, the stub is the first stub that the client wants to get access to is placed into this registry. So it's basically so the registry, as I said, acts like a telephone book. Okay, so then when the client wants to make use of the service, what they do is they look up, they go into the registry and they look up the particular object they want to get access to by its name. Okay, and they're able to, and then the object stub is returned to them, and that's what the client uses to make method calls. So in this particular example, what the client wants to do is to get the second object. So get object here is also a method call, and what they want to do is is to get the stub for the second object, because it also has methods that the client wants to make use of for their particular service. So this is a second way in which the server can give access to its processes and services. So the first way is it places it in the RMI registry, and the second way is that when a call is made on the first object can also return a stub. Okay, so now the client has access to both stubs, the stub for object A and stub for object B, and it can continue to make invocations as needed. Okay, so we use the registry to get a reference to the object by name, or we get reference to an exported object via another remote object. So an important concept in distributed systems is this concept of marshalling. Okay, so it's the concept of marshalling parameters and return values, and this is the idea that we need some kind of a process, and this in this example, it's the job of the stub essentially, and the skeleton, and it's where parameters and return types are converted into formats that can be understood by the network layer. So the network layer, the transport layer, which transports those parameters within messages. So this process of converting parameters and method calls into something that can be understood by the network layer, so we call that marshalling. Okay, so parameters to remote methods must be marshaled by client-side stub for transmission across the network, and also unmarshaled on the server side for actual invocation of the method. Also, we treat return values the same way. So return values are marshaled at the server side and unmarshaled at the client. And there are two main ways in which parameters can be transported. So a non-remote parameter or return value is passed by value. Okay, so the actual value of the parameter is in its entirety is sent over the network. So the way we do that is that the sender serializes the object to a byte stream. So you convert the data, whatever it is, into a stream of bytes. So if this is an object or primitive type or whatever it is, it needs to be converted in its entirety to a stream of bytes that can be transported over the internet, and then the receiver deserializes the byte stream to create a new object. So we call this pass by value copy, where you're sending the entire value of the object or parameter over the internet. Another way in which we can gain access to objects. So one way is to send them completely. Another way is to do it by reference. Okay, so exported remote objects are passed by reference. So we're looking at an example of what we mean by that in a little bit. So in this case, we don't send the entire object over the internet. We only serialize the stub. Okay, so we serialize the stub, and we use the stub to do remote operations on the object at the remote server. Okay, so we don't need to transport the entire object over. We just perform operations on it remotely, and we do that through the stub. So non-remote parameters and return values must implement the serializable interface. Okay, so if you want your objects to be transported over the internet, then the interface, the main type of that object, so it needs to implement the serializable interface. Okay, and both client and server must have class definitions for pass by value parameters and return values, obviously. So how do we do this in a real computer program? So there's a series of steps. So the previous example that we looked at 2 slides ago, so showed conceptually what needs to be done. So we need to export the object to the RMI registry, so that it can be looked up by the client, and then the client gets a stub back and uses the stub to contact the server and get access to their objects, etc., etc. So that's conceptually what needs to happen. So how do we actually implement this within a Java program? So the server side steps are: first thing is that we need to define the remote interface. So the interface is the most important component here because it's what's used by the Java environment to create the stub and the skeleton that we're going to use for communication and marshalling and unmarshalling of parameters, etc. So the remote interface needs to extend java.rmi remote. Obviously, we need to provide an implementation for the interface or interfaces that we make it remote. So there's not much use if we create an interface that's not implemented. So after these two steps are completed, we then can export the remote object, as we saw in the previous figure, and if necessary, bind the object to a name in the RMI registry. So as we saw, we can either bind it to a name in the RMI registry, or we can return it directly through a client method call as well. So there are two ways, as we saw, to return the object. Optionally, at the end of the object lifecycle, we can unexport the object. So at the client side, there are a number of steps as well. So the first thing is to obtain a reference to the object, to the remote object, the stub that provides the local implementation of the remote interface, and forwards calls to the service. And then finally, when we've obtained stubs to all the objects that we want to use within our client program, then always remember to program to the interface. So client itself does not have any service implementation, so you cannot cast to an implementation, so it should always program to the interface. Okay, so next we're going to have a look at some examples to demonstrate how remote method invocation with Java works. Our first example is the most simple example you can have, which is we want to invoke hello world remotely. Okay, so this is just a conceptual view of the example. So we've got a server here, and essentially it has a hello world interface and a hello world implementation of that interface. And what the servers are doing, what we want to do first of all is bind this service within the registry. Okay, so what you end up with is a way to look up a particular service. So in this case, the way to look up is a string hello world, and you also place in the registry a stub that can be used by the client in order to make the remote invocation. So once the server's done this, the client now can look up the registry using this string hello world, and they get back the stub, and they can use the stub to do a remote call on the hello world method, and they get the hello world string back, and then the client can print that if they wish to the console. Okay, so let's take a look at our first example. Let's have a look at the code. So there's our hello world example. It consists of three files. We've got the hello world interface, and you notice here that we're extending the remote interface, and this is how we're making our objects accessible remotely. So this interface has a single method, and it returns a string, and you can all guess what that string might be. We have the implementation here, and the implementation hello world implements the hello world interface, and here is our hello world method. So it returns a string, and the string is hello world.hello world, which is defined here. So hello world is equal to the text of hello world, essentially. And we have a main method as well. The main method contains a number of steps, as we mentioned earlier. So the first step that we want to do is set up our registry. So we create a registry here, and it's basically this line of code here will set up the registry for us. And the next thing we want to do is export the remote interface. So we want to create the stub that can be used by both the server and by the client in order for the client and the server to communicate with each other over the network. So we define the service to export here, and here's where we define the service. We export it, and we give it a name, basically. So we're binding. So within the registry, we're binding our service to the text of Hello World. At the end here, we just have a simple print statement here, which just tells everybody concerned that the service has started. We also have a Hello World client code here, and the Hello World client is a simple class. It also has a main method, and what the client wants to do is connect to the remote service we saw earlier. We establish the service name here, which is simply Hello World. We have the option here. We've added the option here as well to add the full address, the full RMI address of the service. But because we're going to be running this example on this machine only, then we don't need any arguments in this particular example, and we'll just use the Hello World text directly. So we have a simple printout statement which tells us that we're looking for the service, and then the way we get the service is we simply say we go to the naming service, basically the registry where we exported the service at the server. We go there, naming, and we look at the service name. So we look up the keyword Hello World, and that's how we get the service. Okay, and that's all we need to do, really. That's all we need to do. We just need the name of the service. We look it up, and we have the stub at the client side, and the client can now make method calls at the remote service, such as like this. So service.helloworld should return the text defined at the server side, and we should be able to print it on our console here. So let's give this a quick test run. So we go to our server implementation first. So the first thing we need to do is we need to initiate the server. So I'm going to go here. I'm going to run configurations, and I'm just going to make sure that I'm running the right file, the correct file. So it's the Hello World implementation here, and I just run that. Okay, so we're saying Hello World server started. So the server started. Now we just need to run the client. Okay, so we've got our Hello World client here, and what I want to do is run the client side now. So I go to run configurations, find my Hello World client, making sure that there are no arguments here, and I just run it, and yep, so it says looking up Hello World, and then the Hello World string is returned from the service. If you go to the console here, you notice we actually have two consoles. So we've got our Hello World implementation at the server side, which tells us that the server is running, and we also have another console, which is the client console. So example 2 is the echo string example. So whereas the previous example printed just Hello World, in this particular case we want to be able to return any string. So it's also a very simple example. So we've got a server, we've got a client. Decide that the client needs to bind the service within the name server or within the registry, and they have an echo string interface and an echo string implementation. Okay, so the client should be able to look up the registry and get a stub to whatever to the object that they want to be able to call, and then once they have access to that registry, they should be able to once they have access to the object, to the stub, they should be able to call methods remotely. So in this case, they're sending a string that they want to echo. So in this case, it's a simple string called some string. They call the method echo string remotely, and the echo string method simply returns that same string back to the client, and they can do whatever they want with it. In this case, they're just printing it to the console. Okay, so let's take a look at our second example, and that's our echo string example. I have an echo string service here, an interface that extends remote so that it can be exported remotely and used by anybody that wants to use it remotely over the internet. It has a simple method here called echo. All it does is receives a string and it echoes it back to whomever sent the string. So I have my implementation here. Implementation is very simple. I receive a string and I return it. I have a simple server method here, and the job of the simple server is separation of concerns really. So I want to separate the initiation of the server from the implementation details. So I have my implementation details here within my simple implement echo simple implement file here, and I use a simple server to initiate the registry and the server and to bind the service to its name, to a particular name. So I set up the registry here. So I'm using this simple server file here to initiate a number of services. So a number of whatever example I want to run. So I can run my hello world, the previous example here as well. I can run echo string or any other example I want to run from this server. And I do that through a simple method down here called get service. I specify the service name here, and depending on the service name, if it's hello world, we initiate a new hello world implementation. If it's an echo string, we initiate a new echo string implementation. So I get the service, I define it by its name, and then I export the object, and then I bind it to a name. Okay, and then I print out quite simply that this particular service has started. So that's my simple server. So this is all the server side. I've got a simple server, the echo string interface, and the echo string implementation. On the client side, I have my echo string client, and all the echo string client is doing, they use the name of the service to try and look it up. And I print out here, I'm looking up this particular service, and I go into the naming registry and I look at the service name, and that should get me my service, and then that should get me the stub from this, from the registry to the client, and the client should now be able to run any methods on the remote service. In this case, there's only one method, as we saw, which was echo. I'm sending some string over, and it should print out that string to my console. So let's try and run all this. Okay, so all I have to do is initiate the server first. So I have my simple server here. And the way the server works is that I need to, because of this get service method here, I need to specify the service name initially, and I pass it as an argument to my main method here. So what I'm going to do is I'm going to go here, I'm going to run configurations, go to simple server, arguments, and I'm trying to run echo string. So that's my argument here, echo string, and I run this, and that should start up the server. So it has echo string service has started, and now all these steps should have taken place. The registry has been started up, and the service has been initiated and it's been bound to its name at the registry. Now the client should be able to pick up this. So if I go to the client, I should be able to run these steps now. So I'm just going to run configurations to make sure again that I run the correct file. So echo string client, I'll run that. And look, so as intended in line 31, looking up the service name is here, and then I print out, I call the remote service. I want to echo back the text some string as we, and that's happened as intended. So this third example is slightly more complex than the first two, and what we're trying to demonstrate here is pass by value copy over a network. So in this case, we're not echoing a string, we're echoing a text object, which also returns a string, but it's an object that wraps a string. Okay, so we have a server, we have an echo text interface, an implementation for that interface, and so obviously the server is placed the stub along with its name within the naming server or within the registry, the client once again has been able to get that stub so they can make calls on the remote object. So the echo string client is able to call methods on the remote object. So the remote object is a text object. It's a simple text object here, and he calls the method echo text, and what the server does is returns the entire object, the text object, back to the client. And the client should again be able to print that to the console. So in order for us to be able to return a full object over the internet, so there's a simple step that we need to always remember to do. So let's have a look at see what that step is in the next slide. So we've got our echo text interface. Remember, it should extend remote if we want to be able to send that stub over to the client via the registry. It has a simple method called echo text, and it returns a text object. And then we have our implementation class. So echo text implement, which implements our interface, and again it provides an implementation for the method that we've seen above. It basically returns to echo of type text. So let's have a look at the so I think next, okay, we're going to look at the client. So the client again looks up the service via its name, and then it can do something with that service. So in this case, it's calling the echo method on that service, but instead of sending a string over, what it's doing is sending an object of type text. Okay, and that text wraps a string. So so it says here, given the implementation of text on the following slide, the above use of the echo text service will throw a Java RMI Marshall exception. So let's see why that is. So let's have a look at the text implementation. So you see here you've got a simple text class which wraps a string, and it has a constructor and it has a toString method. So and the reason why we get an exception, the exception mentioned here previously, is because we have not said that string implements serializable. So you should always remember that when you want to transport an object of the internet, that you need to be able to convert it into a byte stream, and in order to do that, it needs to be the class that represents the object needs to implement the serializable interface, as we do in this next slide here. So this here's where it's been corrected. We say final class text implements serializable, and now there should be no problem in marshalling the parameters and sending them over the internet. Okay, so if you need any advice on serialization, then have a look at Joshua Block's chapter number 11. Okay, so please try those examples out for yourselves. There'll be a zip folder on Canvas with the examples which we just saw, in addition to one or two other examples as well. So please try them for yourselves. So some problems with remote invocation. So obviously if we want to create distributed applications, that involves multiple components, and with having multiple computing components trying to communicate with each other, we're going to have complexity, and with complexity comes problems. And examples of these such problems include things like increased latency, so it takes longer for things to happen. So when we design our computer programs, we need to think about that. So we don't want to have a lot of chatter, we don't want to have a lot of communication happening between the different components, because that would just slow down the application significantly. We want to have as little communication as possible, so we need to design the interaction between those components accordingly. Independent failure. So depending how you design your application, you need to be careful that if one of the components, one of the servers, one of the services, if one of them goes down, does that mean that your entire application's failed? So we need to think about things like redundancy. What happens if a server fails? How do we replace that in exceptional circumstances and keep the service running so that the entire service doesn't fail? Another issue we need to think about is concurrency. So when we write a computer program on a single machine, we don't really need to worry about concurrency too much. The program runs sequentially from one sequence to the next sequence to the next sequence. We don't really need to worry about our computer doing weird things. Whereas if you write a program that's running between different computers, then you need to make sure that you know which bits are running when. So you might not want a certain number of tasks to happen before other tasks are happening on another computer. So you really need to think about how the different statements between your computer programs are running. Other issues are increased complexity of invocation mechanisms. So as we've seen, we need to think about marshalling of parameters, how our parameters and our variables and our data, how is that going to be transported over the internet, communication protocols, distributed garbage collection, etc. So thankfully nowadays a lot of these issues are resolved for us by the middleware itself. It handles these things automatically, as we've seen, and all we need to do is know about the right annotations or know about the right interfaces that we need to make use of in order to get all these services for free. So the remote invocation abstraction attempts to mask some of the above. So if it's a well-designed middleware, so RMI is a fairly simple middleware, but there are more sophisticated middlewares out there, for example, such as J2EE, which provides a lot of services and masks a lot of these problems, and all you have to do is know about the right interfaces and the right annotations, and a lot of this stuff is resolved for you in the background, and you don't really need to worry about it too much as a programmer. So remote invocation abstraction attempts to mask some of the above, which can be a good thing and provides a familiar programming model. But we need to be aware that invocation, even though the middleware tries to create the illusion for the programmer that they're programming to a single machine, it's not exactly the same as local invocation. Okay, it's not the same. So we need to be aware of that as computer programmers. So within Java's distributed object model, so we need to remember the following points: clients of remote objects interact with interfaces, never with the implementations of those interfaces, and you can only cast remote objects to one of the set interfaces supported by the implementation. Okay. Arguments or return values of remote methods do not follow standard Java pass-by value semantics. So non-remote objects, which means, so these are objects whose interfaces do not extend the remote interface. Okay, so if we've not specified a certain type or a certain object to be remote, so those are pass-by value copy, which means they are serialized. So we need to remember that their classes need to extend the serialized or serializable Java interface, so that they can be converted to a byte stream, so that they can be copied and they can travel the internet. But we can also specify some objects to be remote, and remote objects are passed by reference. So you access the remote object and you perform operations on it remotely without having to transfer the entire object and its data or from server to client, or from client to server. Another thing to be aware of is that the client must deal with additional exceptions. So the exceptions in remote programming become more complex, and as application programmers we need to learn these, and we need to be aware of them. So clients must deal with additional exceptions that result from inherently more complicated failure modes. Okay, and thanks for listening to this talk on Java's remote method invocation.